Alright, so the videos on this topic are about overdetermined and underdetermined systems. So, what that means is when there are either more equations or less equations than the number of variables. So, the first possibility, the number of equations, is more. So, that would mean that we have like x and y, but 3 or more equations. Or 2, 3, or 4 or more equations, or if we had x, y, z, that would be 3, 4, or 5 or more equations. The options are no solution, only one solution, or infinitely many solutions. Now, if we have less equations than variables, so if we have like x, y, z, but only 2 equations, or 4 variables and only 3 equations, or 2 equations, then the system has either no solution at all or infinitely many. There's no way to get a unique solution in that case. Alright, so based on the picture, this is what this video is mainly about, how can we tell how many variables there are, how many equations, and how many solutions? So, these are all two-dimensional objects, or two-dimensional, right? They're a line, so you have to graph them in the xy plane. So, since it's just a line in the xy plane, those are two-dimensional. Therefore, x, y, or 2 dimensions, or 2 variables. So this would be, there's 1, 2, 3 lines. So there's 3 equations. There's 2 dimensions, because it's just x and y. And there's 0 solutions, because graphically, they have to all meet at the same point. Now, they don't all meet anywhere at the same point. These two meet there, these two meet there. But to meet all at the same point, they would have to all cross through the exact same point for there to be a solution. So the next one, again, each line touches each of the other lines but never in the same place, so there's 3 equations because there's 3 different objects, 3 lines, and then there's 2 variables or 2 dimensions and 0 solutions. Now let's look at these. These are all, D through H are all 3 dimensions. You can tell they look 3-dimensional, so they're x, y, z equations. Now there's 2 planes, this one and this one. So since there's 2 planes, each one of those planes represents an equation, so there's 2 equations. So that is 2 equations, 3 variables, and there's 0 solutions because they never meet all in the same place. This has 2 equations because there's 2 different planes, 3 variables or 3 dimensions, and there are infinitely many solutions because their solution is where the graphs cross, and all the graphs, all 2 of them, cross at that one line. That line is an infinite number of points that all are solutions to the system. Here we have 3 planes. It says plane 1, plane 2, and plane 3. You should be able to see this looks like 3 pieces of paper intersecting there. Now all 3 of them meet, and they all 3 touch each other at this one point here. So that's 3 equations because there's 3 pieces of paper there. There are 3 dimensions because it's 3-dimensional, so it's x, y, z. And there is 1 unique solution. This here indicates that this is actually 2 planes that work out to be like the same plane. It's the same thing as in 2 dimensions when you have an equation that ends up giving the same line. So there's infinitely many solutions there for the 2 equations and 3 dimensions. Here, plane 1, 2, 3. Hopefully you can tell there's 3 pieces of paper looking things there. And this is 3 equations, 3 dimensions, and infinite solutions because all 3 pieces of paper meet at this line, which is again an infinite locus of points that satisfy all 3 equations. Here we got 3 equations in 3 dimensions, and they never all touch at the same place, so there are no solutions.